So, given a list of integers called dataset, write a function called automatic histogram to automatically generate a dictionary representing a histogram of the dataset with X bins uniformly distributed over the values. If you look at the example here, essentially what we want to do is take the existing array of integers and just generate bins to almost represent like a histogram. Make
Okay,
sense?
makes sense. Yes.
Cool.
Let me actually ask you a couple questions first then. So first of all, could it be empty?
Let's say that it has to be filled with some values. Yeah.
Okay.
So, yeah, we won't go for edge cases in this scenario.
Okay, and the other question is it sorted? Almost sorted like this example, or not necessarily?
Not necessarily sorted.
Okay. So we have here the data set and we have the number of bins. So basically we look and see it goes from 1 to 5 and we have 3 bins. So then it will have to be 1 to 2. Yeah, I guess the output is here. 1 to 2 and then 3 to 4 and then 5 by itself in one bin. Okay. And then we count 1 to 2. We have 3 values. 3 to 4 we have 2 values, and at 5 we have 1 value. Okay, so let me start that then. So I will define a function, let's call it as the question is asking, automatic histogram, and we give it X and the data set. So data set and X. So let's see, how would I do this? I would, so you said it doesn't have to be sorted, and I'm thinking out loud here before jumping to the solution. So I would love to do this in an O of n time complexity. The thing is, if I sort it, that's already O of n log n, so that's probably not the optimal solution. Instead, we can know what the highest and lowest numbers are, so I wouldn't know what the bins are. So perhaps I should first go over it once to see what the lowest and highest number is, and also store unless it's sorted. So yeah, so let me then start with, so the histogram, or the automatic histogram, let me start with an empty one. And then, as I said, I would like to go over the list to see what, and another question, does it have to always start with 1, or it could start with something else, whatever?
Could start with any number.
Yeah. Okay, so yeah, so I guess I would go over that list. So for I in range, or for I in data sets, I'd go over it and I will test what the minimum. So let me define the minimum. We said it has to be, the data set is not empty, so it will always have a first element. So let me make the minimum number be that first element, and also the maximum number be that first element, and then I loop on it and change those. So if I is less than the min number, I change that, make it min number is equal to I. Same thing for the maximum. If I is greater than the max number, then I change the max number to I. So what I'm doing here is I'm trying to find what the min number and max numbers are, since this is not sorted. The other thing I would also probably want to do is I want to see the frequency of each number, store that, probably store it to another dictionary, which is that would be a hash table that I would use to fill in our final histogram. So let's see if I can do this in the same pass here. I probably could. So let me define that first. So let's call that, for example, element count.
And so this way we don't have to go through the array again, right?
Exactly. Yes. Right. So I would fill that element count. So the way I would do that is I will check if it's there or not. So if I is an element count, then element count at I plus equals 1. I'll increase it by 1. While if it's not there, then I make it there. So element count at I set it to 1. Okay?
Nice.
So that way, I think we have the minimum and maximum, and we have the frequency of each number. Now we move on to filling the actual histogram that we want as an output. To do that, so I guess we need to find the buckets first that we will be filling, or maybe not the buckets. I can fill them as I go, but at least, yeah, I can fill them as I go. But what is the length of or the width of each bucket? That seems to depend on X, obviously, and also whether that maximum number is divisible by X or not, because here, we we had to have three buckets, 1 to 2, 3 to 4, and then 5. If the maximum number was 7, then it would have been 1 to 3, 4 to 6, and then 7 by itself. So it looks like I probably need to check remainder. So let's check. So if that max number modulus x, if there's no remainder, like for example, if the maximum here was 6, then and we have 3, then it would just be simply that max number. Would it be the max number divided by x? It would be the
I
max
think it'd
number
be
divided
by x plus the min, right?
plus the min. You're right. Yes. What I'm trying to find here is the bucket width. So that doesn't depend on the min.
It doesn't depend on the min.
Yeah, so that would be the max number divided by x, since there's no. But wait, what if, for example, that was 9? 9 divided by 3 is 3. Yeah, that would still work. Yeah, I guess that's what it would be. And then else, if that's not divisible by x, that bucket width, what would it be? The max number. So in this case, for example, it's 5 divided by 3. If we do, for example, the integer division, that would give us 1, which is the width in this case. Actually, here we could also have made it. Is it the same? Oh no, if it's integer division, here it was 6, for example, it would have been 1 to 2, 3 to 4, 5 to 6. So it would have still, the width would have still been 1. So I think this should work. Let's check it on a couple examples. If, let's say, if it was 5, then it would work here. If it's 6, then it would work there. If it was 7 divided by 3, it will go here, and 7 divided by 3 would make a 2, so we would go 1 to 3, then 4 to 6, then 7 by itself. Yeah, same thing for 8, and then for 9 it would be here, which would be 9 divided by 3, which is 3 minus 1, so that's 2, which is correct. Okay, so yeah, so I think that is then the correct bucket width. Now, I think I'm ready to go and fill in the histogram dictionary. Okay, so what would I do? I have to start from a minimum, so let's set a variable for that. Let me call it start, for example, the min number that I found. And then while I stop when the start, the thing is greater than that max number, because I will always go, at this plus the start plus the width. So, and they can change the start each time. So I'll say while start is less than or equal to the max number. Let me now have to determine the key of the dictionary, and here the format is, so it's a string from the start dash then the end. Oh, and it could actually be just one number if we are at the final one.
Yep.
So I have to make an if condition to see which one of the two cases. Suppose that it's the last case, then if the start is equal to that max number, then let me call it bucket string, which is the key of the dictionary that we'll be making. So the bucket string would be the string of that max number. Otherwise, the bucket would be the string of the start, and then put the dash, then the string of the end, which is the start, plus the bucket width. But wait, are these all the cases? Because we could actually, if this ended in 7, then it would have been 1, 3, 4, 6, and 7. If it ended in 8, for example, then it would have been 1, 3, 4, 6, and 7, 8, not 7, 9. So there's another case here. So the last one could either be a full from start to start plus bucket width, like the previous ones, or it could be just one number if it's equal to the max, or it could be from the start until the max number. You know what I mean?
Yep.
So there's a third case here that this misses. So let me then add that one. So let's make this one as the else, but then there's another case when the start plus the bucket width is actually greater than the maximum number. So the case when, as I said, it goes to 8. So that would have been 1, 3, 4, 6, and then not 7, 9, but 7, 8. So in such case, I have to go to just 8, not to 9. So the bucket string is a string start plus the dash plus string not, yeah, just the max number. Does that make sense?
Yeah.
Okay, so I think that way we identified the key of the dictionary. Now we need to fill in that key. So how do I fill it in? Just simply, I think we start with saying that what do they call it? Histogram. The histogram, that string and that bucket string start with 0, and then check if it's, we have to loop on the start till the end of that bucket, but I loop on it once because then I'll go to the next bucket and so on, so that way I'm still doing linear time. So for I in, I go from start to start plus bucket with, what do they call it? Start plus bucket width plus 1, because I need to include that last element. I check if this element I is in the dictionary of counts the element count that I filled in earlier. It's there. Then I make my histogram plus equal 1. I add it by the count at that element. So histogram at the bucket string is equal to histogram at the bucket string plus the other element at. So what I'm doing here is, like, for example, if we are talking about the first bucket, the start is 1, start plus bucket width is 2, plus 1 is 3, so we go to 1 and 2. For each of them, we check if it's the counts, and we see the count. The count of 1 would be 1, so we add that. Then the count of 2 would be 2, so we add that. So at the end, that the count of this would be 3. And then,
Nice.
I think that does it.
How do we test this?
Oh, but
And I
just
guess you
one
can test it by
second.
just running, but yeah.
Yes, but just 1 second. If I is greater than the max, I should not count it. I should not. Do I even need that? The start to the end of the bucket. If you're greater, I guess I can. Could optimize it, but it's no big deal. Yeah, let's try that. Let me make return for that histogram and see. I need to think if I missed any edge cases or not, but let's see if that would. Oops, that's a syntax error actually.
Okay.
I meant to say equal here. Okay, let's see what else. Then there's
execution time exceeded. Okay.
So let me. I think there's something here wrong in my logic. So for I in range, from this to that.
If you want to drag
I need to stop.
code editor down, you can as well. And then you can also
Okay.
move the code editor in the middle all the way out, by the way.
How can you drag this a bit down? It doesn't give me.
Oh, so sorry. If you moved your cursor into the middle bar, you see where that bar is in the middle?
You mean this? Oh,
yeah. You can click that, and it will move.
Um,
Oh, just click it, I think, and then you can also drag it on the top right hand side of the code editor, I believe. Oh, maybe not. I thought we had that feature.
I think here. So I believe here I have to check if I is greater than the max. If that's the case, then I have to break. Might have not. So what could be the problem here? I'm having that while I forgot to update it. So.
Yeah.
So I obviously have to, to update the start, make it start, plus I go to bucket width plus 1. Very good. Should I try some solution?
Yeah.
Excellent.
Nice. And you can see the test cases, right?
Yeah, so that's the one that we had as an example. Oh, that one was tricky. I'm glad my code worked for it. It's all 3s, so it's equal to the maximum, so it only had 1 and counted all of them. Okay. Oh, this one was not sorted. But yeah, so my code went to first found the minimum, which was 1, and the maximum, and it knew that, yeah, it's only 1, so it has to be from 1 to 9 and count. Okay. This one, that one was sorted. That one is kind of easier actually. So yeah, it went with all the counts.
What did you think of the question, Ali? And I guess tell me about your thought process about kind of going through this kind of question.
It is a very interesting problem, I think. And honestly, I think it is at the right level. I always think of data scientists as, there is a minimum of software engineering skills and data structures and algorithms that they have to do. But also the bar is a bit lower than software engineers, obviously. So this problem, I think, that's what I like about it. It is interesting. It's not super easy. I think there's some thought to it, and there's edge cases, and also coming up with the optimal solution is probably not super trivial for someone who has not done these kinds of problems. So I think it is a very good problem. I think it's very appropriate for testing data science skills or coding skills for data scientists. Having that said, I think honestly, if I had not done problems before where I had done hash tables, and known how to do complexity of O of n, it would have been way more challenging. So if I'm to give any recommendation for other data scientists, it would be to really do a lot of training and so on. There are some very good problems on interview query and of course on other platforms, but the idea is make sure to know some of the main data structures like hash tables here in this case, for example, because one could very easily solve this, for example, in O of n squared, right? You could do two nested loops and go over this, or as I thought in the beginning, you could sort the array so that you also go through it once.
Yeah.
But sorting by itself is O of n log n, so that's not so good.
Yep.
So I think,
yeah.
So I think, again, very interesting problem. No way for me to have solved it, confidently as I did if it weren't that I had trained before on similar hash table kind of problem.
Gotcha. And I guess for a rubric for grading this kind of question, I guess how would you grade yourself? And then what would you grade, I guess, kind of others in terms of like, different levels of ability and skill? Because I think a lot of people can solve it, but, kind of how many points would you kind of give for a data scientist that was also interviewing, and what would be kind of like really impressive versus like someone that would fail, you think, for this kind of question?
That's a very good question. So first, if I'm to rate myself, but I would love to hear also your rating. I think I did okay, but I could have done a little better. Like, for example, the error that I did that I knew only when I ran it, which was simple but yet important. The problem wouldn't have run without it. That's something that I shouldn't have, failed on. But it is minor, I think. The good things on what I did is I did I think the optimal solution, O of n. You can do this problem better than O of n, I don't think. The good thing is I started with that optimal solution, even though some other schools of thought say, you should start with the brute force solution, even if it's not optimal, O of n squared or O of n log n or whatever, and then do the optimal one. But I think that if you can come up with the optimal one from the beginning, then don't waste time because the time is limited. But yeah, back to my performance. So I think good things is I was able to do the optimal solution from the beginning. 2, at the end, my solution worked fine. 3, I think I asked some of the important questions in the beginning, like whether the array was sorted or not, for example, and so on. What are areas for improvement? As I mentioned, I should have really noticed that mistake that I did by not, updating the counter of the while loop. For example, such simple things are important. I think my code could have been a little slightly cleaner, slightly more concise, but wouldn't have affected the running time complexity, which is the most important thing. So that's how I would rate myself. How I would, generally, how do we rate data scientists on these kinds of problems? We test 2 things. 1, their knowledge of data structures and algorithms, and 2, their fluency in coding and writing code. So some data scientists, I've seen, if you fail on both, then you obviously don't know what you're doing string, and that's a very clear case. But that rarely happens. I think most data scientists I have seen or interviewed or interacted with, they would at least do the second one well. They would be fluent in coding in Python and no problems there. Maybe some small bugs here and there, like for example, when they loop on an array, they have the higher index, a small mistake in the higher index or something, but that's no big deal. I think the challenge I have seen more with some data scientists is the first piece, which is coming up with the right data structures. Like this problem, for example, I would expect many people to jump and solve it in O of n squared or O of n log n or things like that. And as I said, the only way really to be fluent in this is training, to study more of data structures and get more training on these kinds of problems.
Yeah, and I would say that this question specifically is testing that you can do it with like pretty fast runtime, right? Because if you think about a histogram, that could have like millions of data points, right? Potentially. And so if you're doing O of n squared, that's pretty bad on like something with that scale. So I specifically see this question as firstly testing around algorithms and like runtime, and then a little bit of like kind of edge case work, right? Where we're looking at the converting it into a string. And that is its own problem right there, right? Just taking an array and converting it into a string like bins with like the kind of the edge case at the very end where it could be like in a range or it could just be a regular number. That's kind of like a small test on its own. So yeah, definitely probably one of the more harder problems just because it's long in terms of its length, in terms of how much you have to do. But overall, I think, yeah, generally harder for data scientists, probably medium for software engineers. I mean, software engineers might not even know what histograms are, right? It's also testing that you understand what a histogram is and you know how to like, generate this one in real time. But yeah, good practical applications, I would say also, because any kind of plotting library had to do this anyway, right? If we think about that, they basically
Absolutely.
build this. They actually have a tougher one because they actually have to generate, the entire range and then, the whole bins as well. And so I think
Exactly.
it's a great question. So
Yeah. Yeah.
cool,
Totally agree.
good roundup. All right.